happy. This is Mr. Meyer. We are talking 18D stationary points, or as we call them here in the States, critical points or critical values. Now, you know that when we've done graphs in the past and you graph them, sometimes you get what we call a local maximum or a relative maximum. And then there's also absolute or global maximums when you know that the graph goes down and that's the highest point ever and it'll never be a higher point. We call it global or absolute. And then there's also the same thing as minimums. And like we talked about, you'll notice that the derivative will be zero at these points. And that's good to know, right? Because a derivative is easy to find and setting it equal to zero is not so bad. So we can do it. Just be careful. You might have also found a stationary inflection or a point of inflection. So with that knowledge, we can set derivatives equal to zero and we can find those stationary points. So that's what all this is talking about here. The blue tells you set the derivative equal to zero. And what this little chart says is, hey, look, set the derivative equal to zero, do your sign chart. But then the fun part is if it's positive, you know how we did the signs, we got positives, negatives, about increasing and decreasing. Well, think about that. This means the graph was increasing, then it hit the stationary point, and then it started decreasing. That's how you can recognize a maximum. Or the graph is decreasing from left to right, then it hits a stationary point, and then it starts increasing. And that's how you can tell you found a minimum. Or maybe the graph was increasing, then it hit a stationary point, and then it increased some more. That's a point of inflection. And same thing with the point of inflection going down or decreasing. All right, let's go ahead and take our knowledge and go. Find and classify all stationary points. All right, so we're going to find and classify the stationary points. First thing I want to do is find the derivative. So I'm going to find the derivative, which in this case is 3x squared minus 6x minus 9. And then I'm going to set it equal to 0, right, to find the stationary points. I'm going to factor out a 3, by the way. X squared minus 2x minus 3, which is 3. And then what is that? X minus 3, x plus 1. And set them equal to 0. Well, 3 can never equal 0, so that's silly, but x could equal 3 or x could equal negative 1. That's where they are. So number line, right? You could put 1. I always put 0 on there. Huh? I need negative 1, so I need a little bit of room. 0, negative 1, and positive 3. There are our critical points or stationary points now, as they like to call them. And now I will test some points. Now, again, just like always, test points that are in that region, but test them in the factored form because that's really the easiest way. I mean, you're allowed to test them up here, but sometimes that just gets crazy. So I'll pick something smaller than negative 1, like negative 5, and I will get, what will I get? A negative times a negative, which is positive. So the graph is increasing until it reaches negative 1. Then in between negative 1 and 3, like something like 0 would be nice. I would get a negative and a positive. And when I do that, I get a negative. So then it starts decreasing. And then after the number 3, I get a positive. So I'm plugging in 5. Positive and a positive, I get a positive. So the graph will be increasing at first, right? And then it'll start decreasing. So at negative 1, we have a maximum. And then at 3, it will be decreasing. And then it will start increasing. We have a minimum. So at the value x equals negative 1, we find a relative maximum. I almost said minimum. Maximum. And at the value x equals 3, we find or discover a relative min. And there you have them, classified and happy. All right, 13. Find the exact position. Exact position. That means x and y, right? So I need of the stationary point of this. So I need to find the stationary point, what kind of stationary point it is. Then I need to plug it in here to get the y value. I don't know where it is at. And so I will plug it in and hopefully not forget to do that. All right, so let's try. Y prime is equal to Looks like a product rule problem. So the first thing times the derivative of the second thing, negative e to the negative x, plus the second thing, e to the negative x, times the derivative of the first thing, 1. So that is, I don't know, what is that? They both have an e to the negative x in them. So I will pull that out, and I will be left with x minus 2 for this chunk, if you want. Also a negative. Almost forgot that negative. And here I'll be left with a 1. And so that doesn't look so bad. That would be e to the negative x. And then what's here? Negative x plus 2 plus 1. Or most people would call that negative x plus 3. And so now I can go ahead and figure out what on earth. I didn't drop a negative in the beginning, did I? No, I did not. Good. All right. So now I got the derivative. Set that derivative equal to 0. Well, e to the negative x will never equal 0 because that is a decay graph and they approach 0, but they never get there. And negative x plus 3 will equal 0 when x is what? Negative 3? No, 3. Negative 3 divided by 1 is 3. So when x is 3, so at x is 3, we have a stationary point. What kind of stationary point, ask you? Well, I will put my number line. I like 0 on there. I don't know why. There's 3. Pick anything smaller than 3, right? Pick 0. Anything to the e to the 0 power is 1. And so that's 1. And then plus times 3. 1 times 3 is positive. And pick something to the right of 3, like 10. E to the negative 10. That's 1 over e to the 10th, something very small. And but positive. And negative 10 plus 3 is negative, so this would be negative. And so I can tell you that the graph is increasing before 3, but then decreasing after 3. So that means it's increasing. So if I start, it's increasing, and then it starts decreasing. We have found a maximum at the point 3 comma, and now we have to plug 3 into this problem and see what we get. So y equals 3 minus 2 e to the negative 3. That's a 1 e to the negative 3. So either e to the negative 3 or 1 over e cubed, doesn't matter which one you want to put. Most people do not like negatives, so they try to make a positive. And there you go. We found a maximum at the point 3 e to the negative 3. All right. Find the greatest and least value for this on the interval. Now, this brings up a trick, right? Because everyone will see greatest values of maximum, least values of minimum. And so you're like, all right, we're going to take the derivative and we're going to find the maximum and minimum. But when we find those, it's over an interval, and there's a chance that the endpoints might have been higher. So, more maximum or more minimum. And so be careful of that. That is a lot of people will forget that they need to do the endpoints. So here we go. I will find y. Ooh, I did not know I was in highlighter form. Guess I should pay attention. I will find y prime is 3x squared minus 12x. And that's it, huh? 3x squared minus 12x. Yeah, that's crazy. Set that equal to 0, and I will factor out a 3x and be left with x minus 4. So that means x is 0 or x is 4 are our maximums and minimums. Now, the fun part about that is I can go ahead and find out what they are by plugging them in, right? So I could do a test, right? Definitely could do a test if you want, because you're like, no, that bothers me that you're not doing it. There's 0, there's 4, right? Something smaller than 0 is negative. So a negative times a negative is going to be positive. So it's increasing. In between, like 2, we get positive times a negative is negative. And something bigger, like 100, would be a positive times a positive is positive. So we know that at 0, we have a minimum. and at it's increasing to decrease, sorry, maximum, and then at 4 we have a minimum. However, I don't know if it's the absolute lowest point or not. I know it's the lowest point around it, but what about that -2 bothers me, and that 5? So plug them in. When you get plug in 0, that's a piece of cake. You get 5. Plug in. Oh, these are big numbers, and I don't have a calculator on here. That's not good. Um, Plug in -2, and you would get 8, and then that's 4 minus 24 plus 5, right? So 8, 13 minus 24 is -11. And so that's pretty small. And this was, what did we say? Oh, that was a maximum, that's a minimum. So I was thinking 4 would be smaller. I got to plug in 4 and 5. And I don't think I have my calculator. So let me see if I can Barbara Streisand this real quick. While you're waiting, you grab a calculator and check to see what it is. Oh, the excitement. I don't even know what I'm in. 18 something. Probably would have been easier to get a calculator. And it is C D turning point, points of inflection. There it is. We are doing example 14, and they say that -2 gets you -27. Good job there. -27. They say 4 gets you -27, and they say 5 gets you -20. So the greatest value is 5 when x is 0, which you can see on my graph from the local maximum. And the least value is -27 at -2 and 4 because they both are. So this right here is the maximum, obviously. And this right here is the minimums. There happens to be 2 because of the way this region of the graph was chosen. So remember, when you're trying to find max and mins, it's definitely derivative equals 0 because that's going to get you the local maxes and local mins. However, if they gave you endpoints, you got to check those endpoints because it might be just a part of the graph that happens to be lower than those points, right? Imagine a graph going like this, right? And you find the maximum and you find the minimum, but then, and I'm like, oh, good job. But then I restrict your range, say to like from here to here, right? So here's your window now all of a sudden. Well, now all of a sudden this becomes the highest point of the graph because it's an endpoint. This is still nothing. You're like, oh, look, so this would have been a maximum, but it's not. This is definitely the minimum, and this is the maximum of that range, that window range. So watch out, ranges will always mess you up. You got to check the endpoints and look for things in between. That's it. Stay happy. I'll see you next time.